Another important management related to memory and storage is cache management. So if you still remember the storage hierarchy, which allow us to apply the caching mechanism there, who should manage the caching mechanism? Actually, the operating system should. So there are two major design issues which we need to consider, the cache size and the replacement policy. So we all know that the cache is faster than the storage. However, the price of cache is much expensive than storage. Therefore, the cache is often smaller in size. Then, how large the cache do we need? If the size of a cache is the same as the storage, it will be too expensive. So that is not what we want. However, if the cache size is too small, so each time when we want to access the cache to get the data, we found that the cache size is not enough to hold this data. So we need to go back to the storage and get those data. And also, when we cache the data for a new process, so we have to move the old data out. So later, when you want to get the data we just kicked off, so we need to load them back again. So definitely, the performance will be decreased. Therefore, we need to consider the cache size as a design issue. On the other hand, so no matter how large the cache size is, unless it is equal to the size of a storage, otherwise the cache will be filled up eventually, right? So when you want to load some new data in, you need to consider which data need to be moved out. Then you should make the decision very carefully. If you choose to move this old data out, and right on the next period, the process needs the data you just moved out, then you need to get those data back to the cache. So of course, it will introduce additional overhead to the operating system. But if you choose it very carefully, the old data you are going to move out will not be needed for a pretty long time in the future. So the whole system still work perfectly, correctly, without any problem. So then you can improve the efficiency, right? Therefore, the replacement policy has been considered as another design issue. Cache mechanism can be generalized in many places. To the main memory, the register can be considered as a cache. But to the hard disk, the main memory can be considered as a cache. And there's another very important issue need to be considered is the cache coherency problem, and usually happen in the multi-processor system. So multiple processors try to cache the same data, and some processors may update the data. However, the updated data may not be updated by all the caches, so which cause the cache coherency problem. Then let's see our example. So for example, we have a dual processor system with processor A and a processor B. So we have a processor PA, we have a processor PB. And for both A and B, they need the data D from a main memory. So this is the main memory. So we have data D there. And then both processor A and B, they cache data D to their own cache. So each processor has its own cache. So both of them, they cache data D into their cache. And then processor A changes the data D as a D prime and also update D prime in the main memory. So they change it to D prime and also update D prime on the main memory. So since cache of processor B is still has data D, this one doesn't change. So when processor B need data D, it just get D from its cache, which is the old data. So this one is old data. So until data D removed from processor B's cache, so when processor B needed, the data D prime will be loaded into processor B's cache. So if data D doesn't get moved out from processor B's cache, so D will be keep on the processor B's cache. So B will always use the old data. Therefore, from this example, we can see that so when one processor updates the data, the updated data need to be aware by all the processors. So in order to avoid the cache coherency problem. Another important component inside the operating system is I/O subsystem. So the operating system need to hide the peculiarity of hardware devices from users. So to make the I/O easier and convenient for the users to use through the operating system. So for example, we have numbers of I/O devices, such as we have a keyboard, we have a mouse, and a network card. But the different I/O devices, they have totally different features. So for example, the keyboard is pretty slow. So no matter how fast you can tap, so in 1 minute, you may just tap in 1,000 letters or a little bit more than that. However, the network card can be very fast. So in 1 second, network card may load 10 megabytes of data or even 10 gigabytes of data. So although different I/O devices have different features, the operating system needs to hide those features and make them easier for user to use. And the operating system needed to make the I/O subsystem responsible for memory management of I/O, including buffering, caching, spooling. So for example, the speed of network card is super fast, just as we already mentioned, and the CPU may not be available right away. So therefore, the loaded data by network card needs to be temporarily buffered on the network card. So when the CPU is available, the data will be processed by the CPU. So for caching, since the speed of a hard disk or the keyboard is much slower than the main memory, so the data will be cached on the main memory in order to improve the performance of operating system. So at last, for the spooling, and sometimes maybe more than one process want to use a printer to print out something at the same time. However, we don't want the data from different processes print on the printer with interleaving manner, because we hope the printer can complete a job, then takes the next one. So this is called spooling. And also when the users want to access the I/O, the operating system needs to provide the general device driver interface, so which is convenient for the user to use. And the users, they don't need to care about too much details inside the hardware. And the driver will help the operating system to do those kind of things. And then the operating system will assign the task to device driver. And the device driver will control the device controller to finish the task there.